Hey guys, in this video, we're going to be looking at concepts for exponents. I'm referring to paper 1, which is question 1. So these are the things that you need to know before you attempt it. So the first one, this one, simply just saying that any exponent, any variable or coefficient raised to the power 0 is always 1. And the second one is any variable that is raised to a negative number, you can write it alternatively like this, where you take the whole variable and then just bring it to make it a denominator, and then put 1 on top. For example, if, say, we had 2x to the power negative 3, right? So this would be the same thing as you take the 2 on top and then the variable to the denominator. So it's going to be x. So when this comes to the denominator, it becomes positive. So it's going to be x to the power 3, like that. Then moving on to the third one, this is just the exponent rule for addition, right? Which simply means that if you have a common base, which is a in this case, and then we have the exponent, right? You can write it as this, where you take just the base and then you add the exponents. For example, say we have x to the power 3 times x to the power 4. Just take the same base, which is x, and then you add the exponents, which is going to give you 7. Right. And then same goes to the quotient, which is for dividing, right? So for dividing, the difference is that it's a negative, and then for multiplication, you have a plus there. And then the next rule simply just says that if we have a product of two variables all raised to a certain exponent, it's the same as distributing the exponent to the individual variables. Then the next rule is the same as the previous rule, but this time you distribute it to the numerator and the denominator, but it works the same. Then the last rule that we have is where you have, this one is it's an exponent, and then this is a surd. So to go from an exponent to a surd, okay, for example, say we have a cubed root of x to the power 2, yeah. So if we want to go from a surd to an exponential form, we going to have to apply this, right? Which just simply means that this inside, right? You take the exponent that is inside, you divide it by the exponent that is on the outside, right? So here we're going to have x. The exponent that is inside is 2, so it's going to be 2 divided by the exponents of the surd, which is outside of the root. So it's going to be x to the power 2 divided by 3. Same thing when you want to take it back to a root form, you're going to write your root like this, and then the one that's on top on the numerator goes inside, and the one that's outside, which is outside, it's 3. So the 3 will go on the outside because it's the denominator. Okay, now to test these rules, right, we look at questions from past exam papers. So the first question that we have here is, okay, note that all of these questions that we're going to attempt are all solved for x questions. Erase, erase, erase. So to solve this, you first start by simplifying this using this rule, right? We use this rule. We're going to turn this into root form. So turning this into root form, at the same time simplifying this to give us an exponent, right? So to turn this into root form, we said that the denominator is the one that determines our root, right? The power of the root. And then the numerator goes inside the root. So to write that out, we're going to have x to the power 2 and which is cubed root. Then here, going to simplify this to give us 2 to the power 2. So here to solve for x, since we have a cubed root, to remove the root, we can simply multiply both sides. Yeah, multiply both sides by 3. Then also this one by 3. And after doing that, we're going to remain with x to the power 2, which is equated to 2 to the power 2, 3. Right. So for this one, we can simplify this further using this rule, this one, whereby we distribute the exponent to all of the factors. This one is going to be easier because we only have one. Okay, so from here, the last thing you can do is to divide both, root both sides, square root both sides, right? But first, let's start by simplifying this. Okay, going to get 2 to the power, so 2 times 3 is 6. And then if we take the square root on both sides, we remain x equals to, okay, so this is 2 to the power 6, right? 6 is the same thing as 2 times, yeah, 2 times 3. So the 2 is going to go, so remain 2 to the power 3, which is 8. Okay, one thing to note is that an exponent is kind of like an inverse of the the root, because if you have x to the power 2, you can remove the exponent by taking the root, which is going to give you x. And if you have x, yeah, if you have this, since this is 2 here, right, you can remove this also by squaring, right, to get x. So they are inverse operations of each other. If you have only an exponent and you want to remove it, you introduce a root that is that is the same power. So in this case, it's going to be 2. And then x squared, which gives us x. Say you have x to the power 3. To remove x to the power 3, you introduce a cube root, right? Which is going to give you x. Because, okay, let me simplify it, right? So if I simplify this using our rules, this is the same thing as having x to the power 3, which is the inside, divided by 3, which is on the outside, which gives you x to the power 1, which is the same thing as x. So this is what I mean when I say that they are inverse operations of each other. Okay. So to solve this one, there are two approaches that we can take. So the first approach would be to substitute or replace 5x as a certain variable, right? So let's let 5 to the power x be y. So if we let that to be y, we also recognize that this part right here is the same thing as 5x times 2, right? So so if we have that, we can simplify this to be y squared minus 1 all over y plus 1, which is equal to 4. Notice that this part right here is a difference of 2 squares. Difference 2 squares. So difference of 2 squares will simply give us y plus 1 and y minus 1. Oh, okay, so this is valid because remember 1 is the same thing as 1 squared, right? So we can indeed use difference of 2 squared. Difference of 2 squares. Okay, so to continue this, we get y plus 1 in the denominator, which is all of this is equal to 4. So to simplify this, okay, these two add up to give us 1. So we're left with 1, y minus 1 is equals to 4. So y is equals to 5. Remember that y is the same thing, but y is equals to 5 to the power x, right? So we bring back, okay, let me just make some space. Okay, so we bring back 5x, so it's going to be 5x, 5 to the power x is equals to y, no, not y, sorry, is equals to 5. Okay, so 5 is to the power 1. Since we have common bases, we can just drop the exponents, so x is equals to 1. And the amazing part about doing exponents is that you can actually test if your answer is correct, right? So to test if your answer is correct, you can just take the original formula, the original equation, which is 5, okay? The original formula gives us 5 to the power 2x minus 1, I think, all over 5x plus 1 equals to 4. So to test this side must be equals to this side, the right hand side. Okay. So the right hand side, okay, the left hand side, since we know that x is equals to 1, we can substitute. So 2 times 1 minus 1, 5 to the power 1 plus 1 equals to 4. So already here we have 5 squared, which is 25. Okay, so 25, which is 24 divided by 6, definitely gives us 4. So the okay, the left hand side is equals to the right hand side. So our solution is definitely correct. And then the second approach to this question would be to use, so we have 5 2x plus 1. Okay, so it's minus 1. Minus 1 divided by 5x plus 1 equals to 4. So the second way to do this would be to multiply both sides by 5 to the power x plus 1. So 5 2x minus 1 equals to 4 times 5x plus 1. Okay, so to simplify that, we're going to get 5 2x minus 1 equals to 4 times 5x plus 4. Okay, bringing to the other side, we get 5 2x okay, minus 4 times 5 to the power x minus 5 equals to 0. Okay, so from here you can now do what we did here. Yeah, this. So we're going to let 5x be y. Yeah, so if we let that to be y, we're going to have y squared minus 4y minus 5 equals to 0. And then you can use any method of your choice. Either use the FOIL or use the quadratic equation. Right. And then you have to arrive at the same answer. With this one though, it's going to give you two different answers. So from there you have to test if the other one is correct and or the other one is correct. Right. Then you disregard the one that's incorrect. Okay. So moving on to the next question, we have, okay, these ones are a bit different because we have everything is rooted. So to solve these, we can remove the root by squaring, because remember this, the root is an inverse operation of an exponent, right? So to remove the root, which is this one, is it's a square root, so it is to the power 2. So you have to take the square of that. But if it was 3 here, this would also be 3, so that they may cancel each other and give us a 1. So to do that, we are left with 3 minus. Okay, let me quickly double check this. Okay, 26. Okay, 26x equals to, okay, so 3x squared, it's the same thing as, okay, 3 squared is 9, then x squared is x squared. Okay, so move everything to the right hand side. Get 9x squared minus or plus 26. Okay, zero something different. Plus 26x minus 3. We can simplify this by dividing everything by 3. But for this, we're going to use the quadratic equation, which is x is equals to minus b plus or minus b squared minus 4ac all divided by 2a. So x is going to be, okay, so our b is 26, so negative 26 plus or minus b squared, okay, 26 squared minus 4, okay, our a is 9, then our c is negative 3. All of this is divided by 2 times 9. Okay, so to just quickly simplify this, we're going to have negative. Okay, I'm just going to straight ahead write the answer because that should be easy enough to do. So okay, so this is for the positive one, it gives us 1 over 9. Then for the negative one, let's see. So for the negative one, it gives us negative 3. So here we have to test which one of these is correct. First things first, here we have a negative 1, right? So, okay, let's test the negative 3 first. So the root, so we're going to have 3 minus 26, negative 3. Let me check. Must be equals to 3 negative 3 squared. Is it? Oh no, there's no squared. There's no squared. Okay, so this side gives us negative 9. Ooh, I thought this is going to give us a negative 9 because we can't have a negative under a root. But let's just check. Okay, so this gives us a 9. This gives us a negative 9. Okay. 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 So yeah, these are not the same. So means that the correct answer is this one. Even though I didn't do it. Okay, let me just do it. So we're going to have 3 minus 26 9 equals to 3 1 over 9. So for the right hand side, for the left hand side, we have 9, which gives us 1 over 3. And for the other side, we have also 1 over 3. So this one is correct. This one is not correct.